Captain's log. Stardate 1300, March 2nd, 1998. Space, the final frontier. Our mission? To boldly tell about conics and relate them to math we're currently studying in Advanced Math 2. Isn't that right, Nathan?
Yes, that's right, Captain. Using equations we learned in Advanced Math 2, we can show conics in planets' orbits in space. The sun could be considered as the origin, and we can graph the planet's orbits too.
But you may be wondering, what is an ellipse? Well, an ellipse is a set of all points P in the plane such that Pf sub 1 plus Pf sub 2 equals 2a, where F1 and F2 are fixed points called foci, and A is a positive constant.
This is Houston. Say again, please.
A set of all points P in the plane such that Pf sub 1 plus Pf sub 2 equals 2a, where F1 and F2 are fixed points called foci, and A is a positive constant.
No way.
Or in layman's terms, it's an oblong circle.
Well then.
Using the equation a squared minus b squared equals c squared, and any given planet's shortest and longest distance from the sun, the Enterprise and its crew can determine the equation for a planet's elliptical orbit pattern.
But how do we derive this information? We use the shortest distance of a planet's orbit from the sun as the b value, and the longest distance from the sun as the a value. Then use the equation and plug in your variables to determine the foci of your orbit, like this.
Okay, here I go. I'm getting out of the ship. I'm seeing the conics up ahead now. Well, if I can only get my camera working, it'd be great. Look, there's an ellipse. It's the orbit of Mars around the sun. Look at the chart that I'll show you here in a moment, and you'll see the ellipse that it graphs, and like the distances from the sun, shortest and longest, and the methods used to find the foci of these equations.
As you can see by this graph, 155 million miles represents the A value, and 128 million miles represents the B value, showing the longest and shortest distances from the sun, respectively, of the Mars orbit. Using these values in the equation a squared minus b squared equals c squared, we can find our c value to equal 87, which in turn represents the distance of the foci from the sun. This process can be repeated for all 9 planets using the same methods used for Mars.
Oh, wait a minute. I'm slipping. I'm slipping. Somebody put me back in. Oh, God. I'm gonna throw up mashed potatoes all over the inside of my visor. Oh, somebody help me. I don't want to be in space the rest of my life. Oh, no.
Thank you for that wonderful showing, Scotty. It was entrancing yet full of information. I would now like to direct your attention to the view screen where we are...
Look, sir, a Klingon conic!
Houston, we have a problem.
Really? Where?
75 degrees off the starboard bow.
Well, put it on screen, Lieutenant Uhura.
Yes.
We are the race of conics.
Armed torpedoes!
No, we are harmless. We are here to help you.
Help us?
Yes, conics are used in many things. Ellipses, as you mentioned. For example, circles to show information, parabolas in military operation, and hyperbolas in other mathematical ways, just to name a few. Do not harm us. We're your friends. Conics are your friends.
Ah, well, thank God they're harmless, those bloody conics. I thought the Enterprise was dead for sure.
That's a lovely accent you have.
As you can see, the relationships of ellipses and planetary orbits are very close, and this data is used in space exploration, such as our ship. Without mathematics, our warp drives would be out of power, Captain, and we would be orbiting this big black nothing.
Well, thank you for listening to this exploration of conics in space. This ship has seen it all. We must leave now to our next assignment, finding epic poems on Saturn's rings. always remember, with Conics, the possibilities are limitless.
The surface is fine and powdery. I can pick it up loosely with my toe. It does adhere in fine layers, like powdered charcoal. Beautiful, beautiful. Isn't that something? Magnificent sight out here. Magnificent desolation.